Okay, let's take a look at some of the word problems. Supermarket cashiers try to memorize current sale prices while they work. A survey showed that on average, the percent P of prices memorized after T hours is given approximately by this formula. What is the greatest percentage of prices memorized, and how long does it take to memorize them? So, as soon as you see greatest or least, you know you're looking at a parabola in vertex form because the vertex tells you the greatest or the least point on the curve. So we need to put this into vertex form. Let's do it. So the first step is to common factor out whatever's in front of t squared. And if you're not sure if you did it right, you can just distribute in and make sure you have the line previous. So minus 40 times t squared is minus 40t squared, and minus times minus is plus, and 40 times 3t is 120t. Perfect. So now we're going to half and square. And of course, you'll notice as soon as we have an odd number, when we half it, we have a fraction. Do not fear, I'm here, I'm going to walk you right through it. So half of 3 is, of course, half of 3. So we're going to half it and then square it. So half of this squared is 9 over 4. So we're going to add 9 over 4, and we're going to subtract 9 over 4. Now this question doesn't have a constant, so there's nothing afterwards. These 3 we're going to make a perfect square. So we put in the t, we put in this sign, and then half of 3 was this. And then this is still part of what's in these big brackets, of course, because everything in front of this, everything in this bracket is multiplied by minus 40. And then we do this times this in order to get it out here. And if it gets too busy, just do it on the side. What is minus 9 over 4 times minus 40? Well, minus times minus is plus. And here we know that 4 goes into 4 once and into 40 10 times. So that is 90 over 1, or 90. So now that we've put this in vertex form, let's read the question again and see what we have to do. What is the greatest percent? So they want to know what P is, and they want to know what the time is to get that P. So they just really want to know the vertex, because T is this and P is this, right? If this is P equals T, then the point will be TP, and the vertex is 3 over 2, 90. So the greatest percent of prices memorized is 90%. And how long does it take to memorize them? Let's see, what are our units for T? Hours. So it takes 1.5 hours. And that's how we do these word problems. Okay, let's try another one. A ball is thrown into the air from a balcony of an apartment building and falls to the ground. The height h in meters of the ball relative to the ground, t seconds after being thrown, is given by this. Find the maximum height of the ball. So we know what the ball looks like. Here's the balcony of an apartment building, and the ball is thrown and it goes like this, and it hits the ground. Okay? So we know we're going to have a max, and we look here and we see the negative, so we know it's a max or concave down. And we're looking for the maximum height. So we're looking for, this is height, this is time, and we're looking for the h at the vertex, and then we're going to look for the t of the vertex, and then we're going to look to find out what the h is. Well, we'll talk about that after. Let's do one thing at a time. So first, let's find the maximum height of the ball. So we need to complete the square. H equals -5t squared plus 10t plus 35. We're going to common factor out minus 5 out of the two terms that have variables. Right? That's 5t squared, negative 5t squared, negative is positive. Okay. Half of that is 1, 1 squared is 1, so we're going to add and subtract 1. These three are going to be t, that sign, half of that, and then there's still a minus 1 in here. And then what we have is minus 5 times minus 1 is positive 5, so we can collect this, plus 40. So now let's answer the question. The vertex TH is going to be 140. T is in seconds, and H is in meters. So the question was find the maximum height of the ball above the ground. So therefore, max height is 40 meters. How long does it take the ball to reach the maximum height? It takes 1 second. It takes 1 second. Okay. How high is the balcony above the ground? Well, what happens on the balcony? On the balcony is the second, the moment the ball leaves the person's hand. So on the balcony, the ball has not traveled yet, or it has traveled no seconds. So we're going to go to our equation. We're going to plug in. We could go to this one, or we could go to this one. It really doesn't matter. This is actually faster. And we plug in t as 0. So when t is 0, we know h is going to be 35. I'll write it here in case you can't see that. So when t is 0, we have this. So that's 0, it equals 35. How high is the balcony above the ground? Therefore, the balcony is 35 meters above the ground. What would be the equation if the heights were measured relative to the balcony rather than the ground? Well, if we had this curve and it was not starting here, but it was starting here, it would be this. There would be no plus 35. It would just be minus 5t squared plus 10t. And we're going to talk more about some of these things later because this is kind of a bigger discussion than right now. Okay, let's try this question. A lifeguard marks off a rectangular swimming area at a beach with 200 meters of rope. What is the greatest area of water she can enclose? So we've got a rectangle. Yes, your teacher will expect a diagram. So let's call this length and let's call this width. And a lifeguard marks off a rectangular swimming area at a beach with 200 meters of rope. So that means there's 2 widths of rope and 2 lengths of rope to go all the way around, and there's 200 meters to do it. What is the greatest area? So we need to find the area equation. Area is length times width. And we need to complete the square of the area equation. So you'll notice that when we completed the square all the time, previously, we had one variable here. We had h equals da-da-da-da. We had p equals t da-da-da-da. We had x, y equals x da-da-da. But now we have 2 variables. But they gave us this. And the reason they gave us this is so that we can rearrange this to either L equals or W equals, and then replace W or L with what it equals so that this is all in one variable. So let's do that. 2L equals 200 minus 2W when I bring 2W over and divide both sides by 2. And we have that L equals 100 minus W. So I'm going to replace L with 100 minus W. And there's my W. And now I'm going to multiply it out. So I've got 100W minus W squared. And then I'm just going to rearrange it in descending order. So that's negative W squared plus 100W. Okay, so now I need to complete the square of this. So I'm going to common factor out my negative. So I have W squared minus 100W because I need to have bracket W. And then I'm going to half and square. So half of that is 50, and 50 squared is 2,500. Add and subtract 2,500. Take those first three, and I will have W minus half of that was 50. And then I've got this minus 2,500. And then I'm going to do minus 1 times minus 2,500 is positive 2,500. So now let me look at this question. I've got W and A as my X and Y. It's W and A. So the question said, what is the greatest area of water she can enclose? So area is the Y value of my vertex. I know that I did the greatest, not the least, because concave down, right? Concave down with the negative. This is a high point, not a low point. And here, this will tell me my greatest area. So the greatest area she can enclose is 2,500. Do we have units here? Yeah, meters squared. So how do I know where the units are? I reread the question. In fact, you'll notice when I do word problems, I reread the question several times. I read it at the beginning, for sure once, maybe twice, maybe 3 times. I'm marking off what I need to notice and all of that, and then through the middle, sometimes I go back and read it, and then when I think I'm done, I go back and read it and make sure I actually answered the question. Okay, one more word problem to try today. A theater seats 2,000 people and charges $10 for a ticket. At this price, all the tickets can be sold. A survey indicates that if the ticket price is increased, the number of tickets sold will decrease by 100 for every dollar of increase. What ticket price would result in the greatest revenue? So we need to write a revenue equation, and then we need to complete the square because that's the greatest. And of course, there'll be a negative in front of the, just to the right of the equal sign because it's greatest, not least. So we know revenue is money coming in. And money is coming in by the number of people buying tickets times the price of the ticket. So let's just go over this. When let's say the tickets are $10. When one person buys a ticket, it's $10 that comes in. When 2 people buy tickets for $10, it's $20 that came in. When 3 people buy tickets for $10, $30 of revenue came in. So we know revenue is the number of people that bought the tickets times the price per ticket. Now here's the thing. We know that for people, we have 2,000 people that we're starting with and $10 per ticket. I'm not going to use any units in here, just keep it clean and put units in my answer. And at this price, all the tickets are going to be sold. A survey indicates that if the ticket price is increased, so here's the ticket price, and here's increasing. So you see how little by little I'm taking the math or the English and turning it into math in my equation here. If the ticket price is increased, so I added to this because 10 is the ticket price, not that. Ticket price is increased. The number sold will decrease. So the number sold will decrease 100 for every ticket of increase. So when there's one increase, there'll be 100 times that decrease. So $1 increase, 100 less attend. $2 increase, 200 less will attend. $3 increase, 300 less will attend, or 3 times 100. So now, okay, so I left lots of room for my bracket, but I didn't need it. So now what I need to do is I need to FOIL this out. So 2,000 times 10 is 2,000 with one more 0. 2,000 times x is 2,000x. Negative 100 times x times 10 is negative 100 with one more 0, x. And negative 100x times 1x is negative 100x squared. So first, those two equal 1,000x, so let's simplify that. 2,000x minus 1,000x is 1,000x. And now let's put this in descending order. So we have negative 100x squared plus 1,000x plus, right, because nothing's there, so it's a plus 20,000. Okay, I want to find my greatest revenue. This is revenue, so I want to complete the square. So I'm going to take out the 100, negative 100. So I bracket x squared, then that's minus 10x, and that's minus 200. Again, if you're not sure with your zeros, just do this times this is this times this is this times this is that. 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros. So now I'll do my half and square step. Oh, wait a minute. I made a mistake. I didn't mean to common factor out just out of the x's, right? Okay, so 10x, and then half of that is 5, and 5 squared is 25. So I'm going to add 25 and subtract 25. And then I've got my minus 20,000. These three are a perfect square trinomial, which is why we did this whole plus 25 minus 25 in the first place. That sign goes there. Half of 10 is 5. And then we have negative 25. And then minus 20,000. Minus 25 times minus 100 is positive 25 with 1, 2 zeros. And then I have to collect those. So that's 20,000 minus 2,500, which is positive 17,500. Better to have some commas in there. Easier to see. Okay, so now let's see what this tells us. This tells us that we have a maximum. This tells us we're going to increase by $5 the ticket price, and we're going to have the greatest revenue of 17,500. So now let me ask you here, what do we have to do? What ticket price would result in the greatest revenue? So if we're increasing by 5, so this means increase ticket price by $5 to the original $10 price for a new price of $15. So you have to be careful that you answer the question. They didn't ask how much did you increase? They asked what the new ticket price would be. So you have to take the increase of $5, add it to the ticket price, right? Because the price of the ticket is 10 plus the increase, for a total of $15. There you go.